Sophia, you're back on and connected up.
Hear me?
Yeah, good, cool. Hey everybody, I'm Charles Shapiro. I'm the President of World Affairs Council. This is a joint meeting of both our Members Forum and our Young Leaders. So all of you are members of the World Affairs Council. Delighted to have you here with us today. The Young Leaders Program is sponsored in part by the UPS Foundation, in part by the Coca-Cola Company. So thank you to both of them. And the video discussion today is sponsored by the Atlanta Global Studies Center. It's my great pleasure to introduce Sophia Mendoza, who's going to moderate today's discussion with Dr. Patricia Yager. Sophia is a member of the Young Leader Executive Committee and a consultant. So if you need any consulting, she'll be glad to do it. I invite everybody to turn on your camera if you want. If you don't, that's okay as well. If you have questions for Dr. Yager, and I'm sure you all will, please send them using the Zoom chat function. Everybody knows how to use chat. If not, take your cursor, go down to where it says chat at the bottom of the screen and click on it, and it'll pop up on the right-hand side. And please send your questions to Fernanda Luquine. So Fernanda will take questions. If there's similar questions, we'll put them together. We'll make them all shorter. We'll take out all your angry curse words or whatever may be in there so that goes smoother. And then she will send those questions to Sophia, who's going to ask them. So Sophia, I'm going to get off right now. I'm going to mute myself, which I hate doing, and turn this over to you.
Thanks. Joining us today.
I didn't quite hear you.
Oh. All right, how about now? All right, terrific. Sorry for the technological issues today, but we're prepared. So again, thank you for joining us today. We're really celebrating the 50th anniversary of Earth Day. And today's program is titled From Polar Bears to Peaches. We will be talking about the consequences of climate change and how that's impacting both the marine ecosystems as well as people and the ecosystem of the state of Georgia. With us today, we have Dr. Yager, who is an expert in oceanography, and she really has specialized and dedicated a lot of effort and time into really studying the linkages between climate and marine ecosystems. She is currently a professor of marine sciences at the University of Georgia and is a director of the Georgia Initiative for Climate and Society at the University of Georgia. She's also a member of the Georgia's Climate Project and will be telling us a little bit about that. I must say, Dr. Yager, I have to honor that you have an impressive list of publications, 74 of them, which have been cited over 3,800 times. What an accomplishment. In addition to the research that you've done, and you've received funding from US National Science Foundation, NASA, and other prestigious science foundations. I just continue to read her profile and I'm continuously amazed. Dr. Yager, we are so grateful that you're joining us today, sharing your knowledge. For everyone that's online, please join me in welcoming our speaker. And instead of an applause, if you're feeling happy, feel free to join me in using your spirit fingers today. Dr. Yager?
Thank you, Sophia, and thank you, Charles. It's really an honor to be here, and it's kind of exciting to be doing it at all, but plus with this Zoom world, it's going to be fun. So
terrific.
Thank you for having me.
Absolutely. And I would love, I know the previous conversations we've had, you've shared your experience and travels, particularly in the Arctic and Antarctica. Could you tell us what the current conditions are in these two locations?
So may I share my screen?
Absolutely.
Would that work? Okay. So let's see, can you all see that?
Yes.
Okay. If I could back up just a minute, I know we talked about how we were going to do this, and I'm going to ask you if I can take just a minute. Oops, let's see if I can get it to go forward. And I think I need to share. Hang on, sorry. Okay, can you still see that?
Yes, perfectly.
Okay. Can I take just a minute for those of you maybe who haven't thought about this for a while, about the root causes of the changes that I'm going to talk about in the Arctic. The greenhouse effect, if you will, or the global climate change effect, how the combustion of fossil fuels and other human activities are increasing atmospheric greenhouse gases, which then absorb energy and radiate to the Earth system. Here's the increase in various kinds of fossil fuel emissions over the last 100 or so years, 150 years. Most of this is fossil carbon that we've been digging out of the ground and burning and putting up in the atmosphere. And when that gas goes into the atmosphere, it absorbs extra energy. So the sunlight comes in, and then the Earth radiates its heat after it's absorbed that sunlight, just like we do. If you're hotter, you emit a little bit more radiation. Those greenhouse gases are trapping some of that extra energy and holding it in our Earth system. And then the question is, how much of it do we have over the years? Some scientists have calculated we have an excess energy of more than 10 to the 25 joules. That's a hard number to get your head around. So I converted it into calories, because we all know about calories. That's about 1 trillion extra calories on the planet that we're holding. And the question is, where did it go? Most of it by far. We think about how much is in the atmosphere, but the atmosphere is actually a really small sliver of where the heat has gone. And this was kind of transformative when it was published in the early 2010s, where the atmosphere is holding a very small amount of the heat, but the land has absorbed some and the ice has absorbed some, but by far most of the heat that we have excess on our planet has been absorbed by the ocean. And a lot of the processes you're hearing about, the extreme weather events, the changes in hurricanes, the loss of sea ice, the melting of the glaciers, can mostly be rooted back to not so much a warming of the atmosphere, although that is happening as well, but a warming of the ocean. And that's a really key piece of the puzzle that I wanted as an oceanographer. You know, if you had Marshall Shepard come and talk to you, we'd be talking about the atmosphere and the weather and the climate in the atmosphere. But as an oceanographer, one of the things I like to bring to new communities that I speak to is the importance of the ocean and the importance of the water in the ocean and how much it has warmed up. So when you get to the poles, the interesting thing about the poles is that there's this thing called polar amplification. Both the atmosphere, this is a map of the temperature change compared to the late 1800s in the atmosphere. And the red zones are on the order of 6 degrees centigrade or more than 12 degrees Fahrenheit. Other places around you can see have changed as well to a lesser degree. So that's polar amplification. The air temperature in the Arctic is increasing much, much faster than lots of other places. It's also increasing in the Antarctic. And we don't have data in the Antarctic all the way back to the 1800s. If you looked at a more modern comparison, it is also warming extremely fast in the Antarctic. Down here in the right-hand corner is where the ocean heat is increasing, and it is increasing all over the world. Probably you've heard about the coral reefs and how the coral reefs are suffering from the extra warm water. But you can see from this plot that there are lots of hot spots of extra ocean heat, and it seems to be also kind of a polar amplification process. So we've got a lot of extra heat in the high latitudes, both in the air and in the ocean, and that's leading to melting of the ice. So now I'll try to answer your question about ice in the Arctic and the Antarctic. So the Arctic, remember, is an ocean surrounded by continents, covered by sea ice. So I'll tell you about sea ice in just a minute. But we have, you know, Siberia and Russia over here, and North America and Canada, and US over here, and Greenland here, and some islands from the Canadian archipelago. And this white stuff is sea ice. And then Greenland, of course, is covered by land ice. And this is the realm of the polar bear. In Antarctica, we have a continent on top of the pole, a very large, bright white continent covered by glacial ice that is surrounded by a fringe of sea ice. So they're kind of opposites in that regard. The interesting thing about the Arctic is that the predators live mostly on land and on top of the ice, whereas in the Antarctic, the predators are mostly in the ocean, and the ice is a safe haven. So let's talk a little bit about ice. If you haven't thought about ice, you probably know about icebergs. Maybe you know about glaciers. So this is a nice drawing sort of showing that not all ice is equal. The blue ice here is glacial ice, and it's piled on top of the continents, and it comes down as snow or rain and freezes and turns into a glacier after it piles up on top of itself. And the weight of the ice causes the ice to slowly slide downhill towards the ocean. And then it sometimes, when it meets the ocean, it forms an ice shelf that sticks out into the ocean and usually perches on a little mountain or a little rise of the ground, but reaches out oftentimes many hundreds of meters out into the ocean. And those are what break off pieces of icebergs. Then you have an ocean, usually in between, and then offshore is sea ice. Sea ice is actually frozen ocean. It's when the air temperature gets so cold that the ocean freezes. And when the ocean freezes, it leaves behind the salt in the ocean. So you can actually drink sea ice if you want to. It's quite fresh, and if you were stuck there, you could drink sea ice. It's a separation of the freshwater ice away from the ocean below. So sea ice is here, and here's a picture kind of all those together. The ice shelf in the distance is glacial ice. The Polinya, which is a Russian word for pool, is sort of an open water area in between the sea ice and the continent. And then this is sea ice, where there's a seal and some penguins kind of wandering around. So sea ice, as you can see, is about—
Dr. Yager, I apologize. I feel like I'm talking to a screen that's not working. So you're referencing glacial ice and sea ice. Can you tell us, so you've mentioned the differences, and I'm curious, in regards to climate change, is there one that's more dangerous than the other if we lose or as they melt?
Well, so there's sort of two big risks at the moment. If we lose the sea ice, which we are losing, the sea ice is a habitat. Here's some pictures of sea ice. It's about 3 feet thick, and you can see it's the place where the seals live and the penguins live, and the orcas can't get to the seals and the penguins because they're sitting on top of the ice. And the sea ice is melting really fast because when the sea ice is present, it's bright white and it reflects the sunlight away and keeps the ocean cold. It's like wearing a white t-shirt on a summer day in Georgia, whereas the ocean is dark to the sunlight and absorbs a lot of sunlight. And if you melt a little bit of sea ice, it goes away really, really fast because you switch the color of the surface to absorb more heat. And what I want to tell you is that if we lose the sea ice, we lose habitat. We lose a really rich ecosystem that's full of algae. Inside of the sea ice are all kinds of critters, microbiota and algae that live there that serve as food for lots of things. These are krill, these are Arctic cod, and then those things serve as food for things like the seals and the polar bears and the walrus. And if we lose the sea ice, we not only lose the place where these animals feed and breed and refuge, but we lose a whole habitat. It's almost like losing a coral reef. And of course, in the Southern Ocean, we lose places that the penguins can haul out as well. And the penguins are suffering with the loss of the sea ice. And this is just a picture to show you how much sea ice we have lost over the years. We used to have about 4 million square miles in the late summer. So this is the minimum sea ice. The maximum sea ice goes all the way down into the Bering Sea and all the way to the continents in the wintertime. But here's in the summer, the minimum. And the red line is what it used to be just 20 years ago. And now this is what we have now. And so it's disappearing really, really fast.
And Dr. Yager,
okay.
You mentioned this is impacting ecosystems in some of the losers. Are there any winners in this?
Yeah, so as climate changes and the characteristics change, what we see is that the ecosystems that live to the south are moving to the north to take advantage of the change. And as we lose the ice, we're also shifting to a more pelagic or more water column system. And that's, oops, going backwards. That's made conditions really nice for things like bowhead whales that eat the plankton in the water column and need to breathe. And so they appreciate having open water. And other things that also eat plankton are things like salmon and quite a few feeding birds that live near the surface. So you are seeing a shift, winners and losers, with climate change. So the next thing I was going to tell you about to answer the other half of your question is, what about the glacial ice? So the glacial ice, as it melts, it has ecosystem impacts, and that's one of the things I work on. But the major impact is the effect on sea level. Because this is ice that is perched on land. And so as it melts, it actually adds water to the ocean basin. Sea ice floats on the ocean. It's like ice cubes in your drink. If the ice melts, the drink doesn't spill over the sides of the glass. So, but land ice is like adding more ice cubes to your drink, and you can overflow the glass. So this is an ice shelf. The scale of ice shelves is pretty impressive. I'm standing on a boat that's probably the size of a football field, and I'm looking probably several football fields away from this ice shelf. You don't want to get too close because you get hit by falling icebergs. But this ice shelf is about 150 feet above the water line, so about the height of the Tower of Pisa, or part of the height of the Statue of Liberty, and it's 600 feet below the water, so 2 Statues of Liberty below the ice, or below the water surface. So this is a massive piece. This is a massive ice cube. And so when this melts, it contributes a lot of water. And the melting of both Greenland and Antarctica is happening very, very fast and has been accelerating especially since the last decade or two. And this is what the top of Greenland looks like. We have some satellites from NASA that are measuring the loss of ice from space. And again, we're losing hundreds of gigatons per year of glacial ice. This is the ice shelf that I study. And this is the part of Antarctica, this hot spot here. The reason these glaciers are melting so fast, we thought it was because the air was warming, but it turned out we didn't have enough heat in the air to explain how fast these were melting and how irregular the pattern was. It turns out, both for Greenland and for Antarctica, that the reason they're melting so fast is because the warm ocean is coming up underneath that 600 feet below the surface ice part of the glacier. And so oceanographers and glaciologists have had to start working together in the last decade or so to try to understand how the changes in the ocean system are affecting the glacial system. And so I've been attending a lot of glaciology meetings to hear more from the glaciologists about how this works.
And that's wonderful that there's collaboration amongst various disciplines in this, because it's a huge issue. As you're sharing this with us, can you tell us about what this means for cities across the globe? Because from all these statistics and from all that we constantly hear, it's always very alarming. But can you tell us a little bit more as to what does this mean to have glacial melting water?
Glacial melting. Okay, so you probably wonder, most of us don't think in gigatons. A gigaton of ice is a billion metric tons. And so instead of thinking in gigatons, I'm going to have you think in African elephants. Most of you have seen an African elephant at the zoo. So this image is to show you that if you add up all the glaciers in that part of West Antarctica where I work, it's about 300 gigatons of ice each year melting off of the continent. So each gigaton is 100 million African elephants. It's a lot of mass. Another way to look at it is, most of you probably been to Washington, D.C. Maybe you don't think in elephants, but you can think in terms of space in Washington, D.C. If you took the whole National Mall and covered it up with ice to a height 10 times as high as the Washington Monument, that's a gigaton of ice. And we're losing more than 300 gigatons of ice from these areas every year. Now, back to this one image. It takes 360 gigatons to raise global sea level 1 millimeter, and the rise is currently about 3 millimeters per year. So these Antarctic glaciers are contributing about a third to the sea level rise. The sea level rise, just to give you a sense of what's behind these glaciers, the potential or the commitment, if we continue to warm up the atmosphere and warm up the ocean, they've added up the volume. There's a full 1.2 meters of potential here in the Amundsen Sea where I work. East Antarctica has up to 4, 5, 6, 7 meters of potential. If we start to melt all of Antarctica, we're going to have 6 or 7 or 8 meters. Greenland adds up to about 4 meters, 3 meters of ice in Greenland. So if we lose all of them, we're going to raise sea level many, many meters. If you look at what we've done so far and where we're headed, here's the sea level rise total measured. And there's different contributions to sea level. Greenland and Antarctica are the two of the major contributors. The warming of the ocean actually also contributes because warmer water takes up a little bit more space. And so the warming of the ocean just by itself, without adding any more water, raises sea level. So far we've raised sea level about 4 or 5 inches globally. What's coming ahead if we don't do anything is up to 3 feet in most of the very fairly conservative scenarios, 2 feet if we actually get our acts together. And just to give you a sense of where the vulnerability is, this is a great website. NOAA has this mapping program where you can go in and zoom in on your favorite neighborhood and see how much sea level rise will look, how many feet. You can change the number of feet here, and then you can click on vulnerability, or you can look at nuisance flooding during high tide. So most glaciologists that I've been listening to say that we're pretty locked in for 3 feet of sea level rise in the next 50 to 100 to maybe 200 years if we're lucky, but we are definitely locked into probably at least 3 feet with what we've done so far. Now, if we can go and fix some of these problems, we may be able to stop it at that. Otherwise, we're going to have a increase from there. So in terms of what cities can do, a really, really good model is what the city of Tybee Island has done in collaboration with some scientists that were originally EGA. Some of these folks still are, but some of them have moved on. Funded by the National Sea Grant, which is NOAA. They put together, and this is available online, a beautiful sea level rise adaptation plan. And it involves things like, here's the US Highway 80 during one of these nuisance tides that they've been getting increasing numbers of lately. And so, and they made beautiful maps of Tybee Island to see where the vulnerabilities are. And then they looked at the predicted sea level rise scenarios, and they came up with some action items for the city of Tybee Island. And they have been investing in these with both state and local funds, elevating municipal well pumps, elevating US 80, retrofitting their stormwater, and building seawalls. So they had 3 or 4 different action plans to deal with the sea level rise so that they can continue to be a viable community. Okay. So
and Dr. Yager.
Yes.
Sorry, I lost connection for a moment. What a day. You've shared with us the impact also affecting cities and how this could potentially really shift the world we know today, particularly coastal cities. If we could shift back to more of a local, as you talked a little bit about Georgia, can you tell us what does the data say as far as how Georgia will be impacted through agricultural, especially? Or if you could talk about peaches as well. I think that's really a topic that we're curious about as well.
So we talked about peaches when I first met with you. And so peaches, of course, are the state fruit, and everyone's sort of proud of being from the peach state. And the peach industry or agriculture industry typically generates $30 million or more of funds, about 130 million pounds of peaches. But what you might have noticed if you've lived here more than a few years is that peaches are harder to find. And when you find them in the grocery store, they're often from California or South Carolina. So Georgia peaches are now third in terms of production behind South Carolina and California. And the main reason for the decline of the Georgia peach is because they require 700 or up to 12, depending on the cultivar, up to 1,200 hours, chilling hours. And that means that they need cold weather. And we just are not getting that cold weather as much as we used to. Our winters are much warmer than they used to be when I first moved to Georgia in the 90s. And so the peaches are having a harder time. They're not as good quality, and they're having a harder time selling them. This is has been mostly due to the fewer cold nights in the winter. And if you're a gardener, and maybe you don't know about peaches so much, but you maybe buy seeds at the grocery store or at the Lowe's or the Home Depot. It used to be in the 90s when I first moved here, we were in zone 7, which means that generally our low temperatures can get down to 10 degrees Fahrenheit, down to sometimes 0 occasionally. And that has not happened lately. We have shifted hardiness zones to zone 8. So Northeast Georgia is now almost entirely zone 8 instead of zone 7, which means that we don't get those temperatures anymore. And you can see also South Georgia has changed further even to zone 9, which is a place where you used to be South Florida, where you grew citrus and olives and things like that. So agriculturalists, farmers have to respond to this by either shifting crops or shifting the cultivars of the crops that they grow. Like, I know there's been a large movement of scientists trying to create peaches that will grow in Georgia in our new hardiness zone that don't require nearly as much cold weather as the other ones. They're also changing blueberry cultivars. So this is
fascinating.
happening.
I can't imagine the state of Georgia not having peaches or not seeing it as the peach state. Dr. Yager, can you share a little bit more about what you're currently working on within the Georgia Climate Project?
Yeah, so this is the main thing I want to leave with you all, because I can't transmit to you everything that's going on that's great in the state regarding climate and climate change. So please go visit the Georgia Climate Project website. This is a consortia, founding partners, starting with Climate at Emory and joined by Georgia Tech and the University of Georgia, myself. And we have been growing academic partners. So we now, I think, have these 6 or 5, but also now increasing to 9 of the other universities around the state. If you're a member or alumni of a university, please check, and we may be joining as well. This is a goal of a consortia of both scientists and stakeholders that are interested in climate in Georgia. We have some really amazing things. We created the Georgia Climate Research Roadmap a couple of years ago, the top 40 research questions to focus our energies on the things that we need to know. We have a team that's working on climate stories. They're more like the 3-minute vignettes about what's happening to people, both in terms of impacts, but also how they're adapting. We had a very, very successful climate conference in November, where more than 400 people from around the state of all walks of life, not just academics, came and talked about climate change in Georgia. And there's a lot of videos on the website. You can go and listen to some of the speeches. And then finally, we're working on a team of a subgroup of us is working on Georgia Drawdown, which is finding solutions to the climate crisis in Georgia. So I did want to tell you a little bit. So my mom always reminds me about don't talk about climate change without giving people something to hang on to, because otherwise you just depress everyone, which I totally get, because I get depressed sometimes too. So what can we do? The things we can do break down into, and the Georgia Climate Project is on top of these 2 things. One is we try to mitigate. We try to solve the problem of the CO2 and the other greenhouse gases in the atmosphere. We try to pull them back down, or we draw them down, or we stop putting as many up there. So that's one approach. The other one is to try to adapt to changes that are already in the pipeline, like the sea level adaptation plan I talked about, or building green cities that have more grass and more trees, so the urban heat island effect is not as intense. But the main one is the mitigation is reducing electricity from fossil fuels such as coal and natural gas, switching to solar and wind to conserve energy, changing the way we think about transportation, stop driving every day in our cars that use a lot of fossil gasoline, less air freight, fewer flights, try to take public transportation. These are all things you've certainly probably heard about. If you're interested in digging deeper, this is a really great resource that's not Georgia specific, although you'll find probably that some of the funders are from Georgia, but they have been looking globally at a balance between cost versus benefit of which are the best investments for solutions. And we have our own version of drawdown in Georgia. We're the first state to have a statewide Georgia drawdown or a statewide drawdown project. And again, this is funded by the Ray Anderson Foundation. Go to www.drawdowngeorgia.org, and they're working on specific solutions for the state of Georgia, whether it's electricity generation or transportation, built environments, food systems, and forestry. We have some of the most abundant forests in this state, and that's a huge resource to help with climate change mitigation and adaptation.
Thank you for sharing these resources, Dr. Yager. And we have a couple of questions.
Great.
The first one is from Ambassador Shapiro. He asks, do you think the COVID pandemic could result in Americans having greater faith in science and experts like you?
Oh, I think that would be a lovely outcome from a terrible thing. I don't know for sure. I think we're having, I mean, I'm not a public health scientist, but I have lots of friends who are, and I see that they're having trouble communicating their science effectively. So I don't know what the future holds for us. I think there's a lot of folks, the way we teach science in this country is not very effective. It tends to be about the facts, and so facts instead of process. Like science is a process of curiosity and exploration and trying to figure something out, and we have taught science in a way in this country that does not encourage curiosity or exploration. We've kind of I mean, I watch my kids and what kind of science they're learning, and it's all about the facts. And the problem is facts change in science. So I think we have a lot more work to do. I'm not that optimistic, unfortunately. I wish we could be more optimistic, and we'll see what happens with COVID. I don't know.
Well, your honesty is appreciated. Another question we have is from Becky Carter. The question is, the ice, you mentioned that the ice melt is caused due to ocean temperatures. So what is causing the ocean temperature to rise?
So the ocean temperature is rising because the greenhouse gases are trapping the heat in the Earth's system. So when the solar radiation comes to the Earth's surface, it's absorbed by the land and by the ocean. And then just like anything that has a non-zero temperature, it emits long-wave radiation or heat back out to space or back out to the atmosphere. But in this case, the atmosphere says, okay, I'm gonna take that back, and then the atmosphere is warming, and it's transmitting that heat back to the ocean. So the surface ocean is the place where the most warming has occurred. So it's clearly coming originally from the atmospheric trapping.
So we can say it's a trapping of heat based from radiation from the sun.
From the greenhouse gases, yeah.
Correct, terrific. And we have one more question. It says, how do you deal with people who simply reject the idea of climate change?
Oh gosh. Well, first I try to listen to them and figure out where they're coming from and on what basis they're basing their opinion. And then if I feel like there's space to change their mind or to inform them a little better, I talk about my own personal experience, like that I've been to the Arctic for 25 years now, and the Arctic that I visited as a graduate student is completely different from the Arctic I visited this year. I try to give them sort of personal evidence. I also try to think about maybe something that's important to them, like maybe they're trout fishermen, or maybe they're a farmer, or they're a gardener, or so there's something called climate nostalgia, where if you're old enough to have experienced Georgia's climate 20, 25, 30 years ago, you might remember something, like maybe you had more snow days when you were a kid and you went to school. So you try to figure out what they remember or what was important to them when they were kids, and you get them to think about how things have changed, and sometimes they'll come along.
That's terrific. Thank you so much for joining us today and sharing your wisdom, all of the wealth of knowledge that you have. My sister, I don't know if she's joined, but she's a student at UGA, so I'll definitely send her your way to say hello. Once this is all said and done.
That
So
sounds
now,
great.
thank you again.
It's been my pleasure.
We will have Ambassador Shapiro close us out.
Dr. Yager, I want to thank you so much. And I have to tell you, I've never heard of climate nostalgia, but as soon as you said it, it's like, bam, you know,
Yeah.
that just, of course.
Yeah.
I mean, it must be frustrating for you to dedicate your life to science and then people just say, no, that can't be right, right?
Yeah, it's a little bit frustrating. It's like you said, you know, there's not trusting the science. Yeah, it's frustrating sometimes.
Well,
You just keep trying, right? It's just like anything else.
I hope that's one of the things that, although like you have my doubts, that is a result of this pandemic is that, you know, the people were talking about it and here's what's going to happen and it's happening. And
I think
it'll.
Yeah, if I can interrupt you, I'm sorry.
Sure.
One of the things that's happening is our air is cleaner. I
Yeah.
don't know what it looks like in Atlanta, but it's bluer here. And, you know, people might notice that and say, well, that's interesting. We managed that in 1 month or 6 weeks, you know, and so maybe there's space for thinking about how we can modify things.
Well, in northern India, people can see the Himalayas for the first time in 40 years. So
Isn't that interesting? Yeah.
yeah, so it is just amazing. Yeah, thank you so much. I really do appreciate it. Sophia, you've been a terrific moderator. I'm guessing the Francisco Mendoza who's watching this might be related to you.
Yes, he was my father. Hi, Dad. Thanks for your support always. And my sister maybe too. Thank you, guys.
Oh, that's great. That's so cool.
It's been
I
fun.
want to thank all of you who've joined us for this today. This has been a terrific members forum, young leaders program. I want to thank the Atlanta Global Studies Center for sponsoring this program today. You may have noticed if your inbox is like mine, you're flooded with emails saying today is Giving Tuesday. In case you missed it, today is Giving Tuesday, and the World Affairs Council would love for you to go to our website and make a donation. We're not doing in-person programs, so we're doing programs like this, and it is hit our revenue just like everybody else. So if you've got anything to spare and you like today's program and the other programs we're doing, please go to our website, make a donation. Tomorrow at noon, we have the European Union Ambassador to the United States. His name is Stavros Lambrinidis. He's going to talk about the European Union, its response to the pandemic, US-EU relations and where we're going, and the world economy and how he sees the recovery in Europe. So please join us tomorrow at noon. On Thursday, we have Meg DePalma from Prudential. He's going to talk about the special issues and challenges for women as they do their own financial planning. So please join us for that. And on Friday, we have Dennis Lockhart, the former CEO and president of the Federal Reserve Bank of Atlanta, now teaches at Georgia Tech. And he's going to discuss his view of the post-pandemic economy, post-pandemic economy. It's not as catchy as climate nostalgia, but anyhow, we'll go with that. Anyhow, thank you very much for joining us. This has been a really terrific 45 minutes. Thank you, Dr. Yager. Thank you, Sophia. This has been terrific, and I hope to see all of you tomorrow at noon with the European Union Ambassador to the United States. Bye.
Have a great day, everyone.
Bye-bye.
Thanks.